Alright, we're here to learn what a square is and what a rhombus is. The plural of rhombus is rhombi. It's the only one that's a little bit unique. The definition of the rhombus is a parallelogram with four sides congruent. Some of the properties, the diagonals are perpendicular bisectors of each other. Now because it's already a parallelogram, they already bisect because it's a parallelogram, the diagonals already bisect each other, so this piece congruent to this, and this one congruent to this one, but not necessarily all four half diagonals are congruent. If that were the case, you'd have a rectangle. If it was a rhombus and a rectangle, we'll learn what happens with that soon. The rhombus, the diagonals also bisect the angles, and we're talking about the angles formed by the sides of the rhombus. If it were the case that we knew that we had a parallelogram in blue, and we knew that these diagonals were bisected, then we wouldn't even need to know these ones, or these ones, or these ones, to then know that this is a rhombus. If it's a parallelogram and the diagonals bisect the angles, then we're good to go. And we know we have a rhombus. In trying to find the perimeter, first we'll take, I'll find the perimeter of a rhombus with these diagonals. Test taking tip, if they tell you the diagonals are 12 and 16 in a rhombus, the rhombus is not the one that has congruent diagonals. The one that has congruent diagonals is a rectangle. So sometimes you can use the test information, you can use the homework information to help yourself with a problem, try to keep things straight. We do know the diagonals are perpendicular, and that's what makes a right triangle here unlocks us into Pythagorean triples. We can work with the 6 and the 8, with the 3, 4, 5 triangle to get a 10, and then 4 times the 10 to get the 40. There are units on here, so we should make sure to include them. This should be sorry about that. We should be at 40 centimeters for the perimeter. It would be centimeters squared if it was an area idea, but this is a perimeter idea. It's adding up one-dimensional units to get centimeters. In example 6, we're to find the longest diagonal of a rhombus with a perimeter of 40 and one angle of 110 degrees. So if we know the perimeter is 40, we can conclude that the sides are each 10. So I made the side equal to 10. All the sides are 10, I'll only show it on the bottom. If I know that we have an angle of 110, then I'm going to take my obtuse looking angle and I'm going to divide it in half to get 55 and 55. That means I have a right triangle that has a 55 as one of its acute angles and 35 as its other. You can find that 35 by doing 90 minus 55. You could take the perspective of the 55, but I'll choose to show the perspective of 35 instead. From the perspective of 35, the side we're trying to find is the adjacent. And we're given the hypotenuse. That means we're going to use the cosine function and work out the algebra. The hidden part of this question that really needs to be dialed up is that we're looking for the longest diagonal. So the longest diagonal is going to be across here, not because it looks bigger, and we have drawn the picture so it fits, but the reason why it's a bigger diagonal is because in this triangle 55 is bigger than 35, so the side across from 55 is bigger than the side across from 35. If you did everything the same, but you'd really like to use the perspective of 55, then the O and the A flip places, and we would be looking at the sine function is y over 10, And I've shown the algebra a little bit different here as well. Instead of getting about 8.19, then multiplying by 2, I've absorbed my 2 as 20 times the sine of 55 and got an answer of 16.38 as my longest diagonal. Here are a couple images that really help us understand what's happening in a quadrilateral. First of all, a square is a rectangle that's also a rhombus. And we have this flow chart of what quadrilaterals do. Once we have quadrilaterals become parallelograms, they can become rectangles and rhombi. If they are both rectangles and rhombi, then they are called a square. Looking at quadrilateral as the giant sample space, there's parallelograms which are in that sample space, and inside of those are both rectangles and rhombi. Rectangles and rhombi are not mutually exclusive. In fact, if you are both a rectangle and a rhombus, then you are a square. So this area in the middle is where the squares live. The property that you really want to understand from squares is that the diagonals create 45, 45, 90 triangles. And here's the work for this problem. For example 8, we're looking at finding a rectangle, perimeter of 20, and a whole number of sides. We'll find the dimensions to give us the smallest area. So if the whole perimeter is 20, we know that x plus y is half of the perimeter, so x plus y has to be 10. So we'll get it this way. 1 times 9, 2 times 8, 3 times 7, 4 times 6, and 5 times 5 would be our possibilities for a rectangle. And the one with the smallest area would be 1 by 9. The most hot doggy of all those shapes, not the most hamburgery. That would give us the least area. These classification problems can be tricky. I chose to show them all with distance, as I prefer distance. Some people prefer slope, some people prefer one of each. There's definitely more than one way to do this problem. I've just shown it with all distance. First of all, for the sides, all of them being 3 root 2. And for the diagonals, 0 squared and 6 squared in reverse order, as this is 6 units high and 0 units wide, and this diagonal is 0 units high and 6 units wide. So each of those actually is a distance of 6. Since we have all 4 sides congruent, we can conclude it's a parallelogram and a rhombus. Since we have the diagonals congruent, we can conclude that it is a rectangle, and because it's both a rectangle and a rhombus, we can conclude it's a square. We'll pick up on the 6.1 notes in just a minute.